on digital transformation with DCC hands-on training. My name is Jarilat Yogunbadi from NUMT, Thailand. I am the lead of the DEC Focus Group Task Force, and I have the honor to serve as the chair of this session. Yesterday, we all enjoyed the remarkable session on digital transformation, setting the stage for the deeper explanation. We will continue it today, and we saw how your active participation made each session dynamic and insightful. Today's workshop focused on the stakeholder feedback and the case study, and we brought together distinguished experts to share their knowledge and insight. We hope that through today's presentation and discussion, without further ado, let's get started with our first session of the day. It is now my pleasure to introduce our first speaker, Dr. Anjali Sharma. Dr. Anjali Sharma is a senior principal scientist at the National Physical Laboratory of India, NPLI, with over 20 years of experience across corporate, academics, and research and development sector. She represents NPLI at the CIPM Forum on Metrology and Digitalization. She holds a PhD, bachelor degree, master degree in computer science, and previous work at IBM India Software Laboratory. Her research focuses on software quality, machine learning, and digital metrology. Today, she presents stakeholder feedback on DCC in APMP. Please join me too in welcoming Dr. Anjali Sharma.
Thank you, Charua, for such a nice introduction. Just like to share, am I audible clearly?
Yes, your voice clearly.
Okay, great. So I'll start sharing the screen now, and once again, we'll able to see.
Yes, it's okay,
Okay.
perfect.
So can I go ahead?
Yes, you can go ahead. Thank you.
Thank you. So today, I've been asked to present this APMP stakeholder viewpoints on digital calibration certificate. This is the talk that we also presented in one of the sessions in this year's Forum MD meeting that happened in February 2025. This work is not only my work, but this has contribution from 5 other NMIs of APMP, including MSL New Zealand, A-Star NMC Singapore, NMI Australia, NIM Thailand, and Chris Korea. So apart from me, Blair Hall, Kushan and UC, Mark Beliko, Naren and Paria Thonglan, and Van Ho Chao, whom you heard yesterday as well, they all have contributed in this work. So why we are presenting this is that within us as an NMIs, we feel that yes, in long term, calibration certificates will be digital calibration certificate. But this approach will be successful only if we achieve broad willingness of internal and external stakeholders to engage with DCCs, and there is an interoperability. So we have 2 drivers. The NMIs are ready to push this concept, and the stakeholders, internal as well as external, need to have that pull. Then only we can have the successful model of DCCs. In some regions of APMP, there has been very close engagement between NMIs and clients with these 2 drivers enmeshed. And APMP being a combination of very diverse economies with different mix of industries, regulation and top-down regulation approach, we just try to find out what is happening in different parts of these NMIs and what is it that we can actually study and identify from this. So we identified that the aim was to understand stakeholders' viewpoints And the NMIs are at different levels of implementations. Few have conducted some sort of surveys as well. So these NMIs have surveyed their clients to identify their drivers and concerns. And here we present the major findings, implementation status, and path ahead. So the approach taken to assess the need for DCC and the lesson learned is what we try to focus in this study, with an aim that we adjust our DCC plans to best meet the needs of broad and diverse stakeholders and improving our communication to address misconceptions and fears of our stakeholders. So we'll start with NMI Australia, which has really done a very extensive study spanning from 2020 to 2023. And in 2020, they identified these digital strategy and strategic priorities for NMIA. Then in 2021, they conducted a two-yearly client survey with 236 respondents. And in 2022, they actually deployed the DCC proof of concept project with 13. They actually conducted deep dive stakeholder interviews, 13 number of interviews. And finally, in 2023, the proof of concept project line experience with four internal NMIs thing was presented. So in 2020, they highlighted that NMI strategic priorities has been leading and coordinating Australia's measurement system. So with DCC, they wanted to show, DCC is a point where they wanted to highlight that digital capability is very important. And in this way, NMI can position itself as a leader in this domain for Australia. Then ensuring Australia's measurement system is trusted. So yesterday also we heard that DCC has got security and integrity aspects, and that can help this strategic point. Then enhancing trade, investment, and economic growth. It was highlighted that there is a digital trade and data standards, and DCC has the potential to reduce this trade friction, delivering critical measurement systems to identify that DCC's enhanced service delivery and evolving capability to serve key economic sectors. Like they thought that DCC in 2020, they thought DCC can be a stepping stone to more sophisticated use of technologies, digital technologies, and data. This can open up additional opportunities for NMI Australia. So their long-term aim has been to NATA labs making and promoting DCC's use, because if the clients see a value in it. And NMI Australia does not aim to have a rollout or an NMI Australia driven DCC. They had this approach where they want to learn by doing, and most of us has been doing like that in APMP, most of our labs. And what they did is that they built upon the PTB DCC schema, and rather than simply saying that this only XML will be provided, they went along with this incremental experience approach where they have this PDF and which they were giving as a report or a certificate to their clients, plus the XML machine readable data, rather than uh, going well ahead with something that people can reuse and adapt. So they went ahead with PTP schema, but with such that it allows easy addition of new features that they would have interest in. And then finally, they wanted to have an integration with what the technologies already exist. So they had this use of their own TMARS is their own system, and with uh, PDF embedder added in, so that you have a PDF generator and then you have an XML embedder with it. So simple Excel sheet added to any client user data analysis spreadsheet that can allow you to give these XML files as well. In the second year, so this came to 2021, where they found that to the question that metrology institutes and calibration laboratories worldwide could in future use DCCs, what do you see as the main advantage or risk for your organization? So the advantages were manifold, that their stakeholders or the clients are with increased document security and legal status and embedded machine readable calibration metadata. But the other things that they found is that there can be a risk to document portability and open access, and many people said they don't know or other something like that. This is the slide which is very important, where they actually had these deep dive interviews with 13 stakeholders and tried to find out from different sort of these like they interviewed internal stakeholder, they interviewed security conscious user, they interviewed small industry lab, and they interviewed the large calibration lab. So this is shown with a small dot that you can see in these square brackets. And what's highlighted is that it can be this feedback can be grouped into actually four places, which is the overarching process, the calibration certificates, the trust, and the measurement study. And in the overarching process, the people said that it would be great if we could get reminders. So that's something that, yes, it can be done, or a central place to access all the certificates over last several years. However, they also pointed out that there is a large upfront effort in mapping this test result data to the XML text that are being provided, or it's going to be a pain to get digital office to approve the installation of verification software not currently in the catalog of the organization or a company. Websites are probably okay. And then uh, how can we be sure that whatever standard we adopt or whatever DCC schema we adopt will remain sustainable and consistent for the next few decades? Customers, many of the times, they're not currently requesting digital certificates, but once it transitions down to labs, we'll probably end up these labs then to our own customers. So, but at other point, they say that it wouldn't hurt. A machine readable calibration certificate wouldn't hurt, but it would probably more useful for labs with a larger volume of requests, where they actually the request of importing this data into the machine is quite large, rather than for the small industries. Then we come to the survey from the CRIS, where they did the survey target with the calibration lab, and they approached 770 labs, but the response rate was they could only get 60 response. And they divided their survey into four major categories, where they want to identify what is the understanding and demand for DCC, what are the obstacles that they see when if they want to implement DCC, and what is the request for support from an NMI if the DCC is implemented, and what are the expected effects. So overall, what they found is that the demand and understanding for DCC, the success was that they know a little bit, and that is why we are having these workshops, these talks, so that we can have a more better understanding of what DCC involves and what it is about. So there was this answer where 52.8% said that they know a little bit about DCC. Then they divided into this survey of the CRIS from the perspective of customers receiving the so if I am a customer who's receiving this CRIS certificate, what is their outlook about this? So what is the demand for DCC conversion of CRIS certificate? There is not necessarily a very big demand, but the customer feels that it is necessary to consider the DCC conversion. What benefit if this certificate is changed to DCC? The customers believe that there can be an improvement of efficiency by automating calibration report management part. That's a report management part. And then once they talk about concerns of if the CRIS certificate is converted to DCC, so they try to highlight that there is a lack of technical capacity in small institutions. That was similar to what NMI Australia stakeholder interview also highlighted. And there is a confusion due to differences in calibration report format with existing clients and institutions. So we cannot, in DCC, we are not saying that the report which the customer sees has to be same, but we are talking more about how we can map this schema to the reports that being generated. So that mapping part, rather than trying to harmonize the report format for across the institute. So, but people think that this can be an issue. An expected problem if Chris is changed to sorry is that there is an increase of workload and there is not such a big demand. So 80% is like they're saying that it's not much required. While if as a provider who is issuing the certificate, what are the difficulties that they perceive in DCC is that it is a cost burden, it is an increase of workload, and there is not much of a customer demand. So as you can see, 80, 90% they're seeing from the perspective of an issuer, they're seeing a problem. While what are the issues if the certificate is changed to DCC? So then 55% or so again says that there is a duplicate investment because there is no utilization by the client. And then again, the manpower to handle all this. Advantage, again, there is 70% people feel that it will improve the productivity by reducing issuance time and it will improve the efficiency by automating issuance management. But before that, this preparation of having a system ready, the manpower ready to build onto this DCC was a concern. And they highlighted that preparation is necessary. It, like most of the institutes think that preparation is necessary, but some of them are saying that they are not prepared at all. And then in the survey comparison analysis, the Chris identified that there is this positive opinion that there is an expected tight cost savings, and the only benefit expected in the current. So we need to identify a new business model which creates more of an opportunity for the end user or the customer to see a pull value for the DCC. While right now they found that there has been more concern about increased time and cost as an additional investment, and mm, it's still seen as a problem of NMI. Like NMI wants to push, but there is not enough of a pull where someone it is that's a quite a strong comment that it is self-satisfaction of metrologists or no additional profit models expected. The request is to have this because you cannot build the infrastructure in a day. You cannot have this manpower trained in a day. So it's always important to have this incremental approach where we are doing things and we are learning things, and that's percolated down um, in the organization and two systems, how they can work side by side for the time being, and then bring out these new business models where the industry, until unless it doesn't see the economic benefit out of this, there will not be such a big pull from their side. So everyone's situation is different. You find your target stakeholder for which you want to implement this DCC. Then this is who will pay for this or infrastructure for the change in the system if required or for the manpower. So who will pay? And then what can be the business model which is beneficial for both, and then there has to be these priority settings and identifying what can be done in a short period of time. So they with the path ahead they identify that there can be project proposal for DCC DSI implementation. So this was somehow rejected, but planning of technical side like autonomous machine-based quality infrastructure and how the NMI's role can be planned to list of to set these priority settings of the NMI and how these internal problems they can identify and resolve them. That was something that they were able to get ahead with. When we came to NIMT, the sample size was about 37 institutes, including customers, accreditation lab, legal metrology, and 81 people from these 37 institutes filled the survey with 9 number of questions, and they want to identify what are the pros and cons of developing DCC prototype for calibration laboratories. So they identified that the DCC provides with a long-term preservation of the calibration data and the calibration certificate. And there is an ability for direct traceability, and this will reduce paper and cost. But at the same time, there is not enough document storage space, and that if the data is insecure or something, then there can be a loss of data, while reduce the certificate issuing time. And that's what we are seeing in the previous two slides as well, two surveys as well, that they see this as in productivity or efficiency increasing. That's what is expected with more security and creation of DCC. While there is a very strong need for financial support for these DCC systems and signature and data forgery or changing the organizational culture, because this brings a digital shift in an organization. So the participants agree that calibration format to digital is very required, but with those concerns that they highlighted, that and the concerns were depending upon the type of organization or job position. The private sector has concern about changing organizational culture, but the government sector has concerned about staff's lack of new knowledge to support this system. And for the laboratories, head and staff are concerned about the operation process, while the department head focuses more on budget and cost. So for the path ahead, as we already saw yesterday from Jaria's presentation, that they have this DCC web portal from NIMT for users in Thailand, and they want to develop a DCC prototype to accommodate a range of equipment, which they might be doing sometime in 2026. And with 2027 example of a digital NQS system designed for Thailand. A Star, now the three labs that I discussed further down, they have not conducted a formal survey. However, through the stakeholder engagement sessions following feedback they have received, the general sentiment is that wait for DCC to be standardized before investing in its development. And because early investment could lead to high cost of changing it later for standard compliance. They are doing the internal trials and evaluation on DCC and to find out the actual needs in industry, whether a PDF A3 report with embodied raw data is sufficient for the near future. And the important part here is that they're trying to explore IEEE 1451 standard to understand what alternatives are available and how they may leverage from standards like these. They have now coming to MSL New Zealand, they have surveyed customers, but not a dedicated DCC survey. They interact with customers by doing telephone interviews, which are written up and discussed with Quality Council. From these interviews, they've identified there is no client pull towards the DCC, but there is an interest towards more digital delivery of service, which we have identified from previous surveys as well. Internally, there is only a few staff in MSL overall, and also very few staff is willing to invest time in digitalization. They need to develop clear conceptual foundations for digitalization of metrology, and which is what they identify as their priority area, and they're working with NCSLI in this direction. The intent is to use PDF A3 as an intermediate format that is composed, we all know, human readable and the machine readable content, like the XML can be embedded into it. Incremental strategy, again, seems to be best suited to show others by example what are the benefits, and then how to enable customers to able to verify the integrity of digital documents. This part where a cloud-based verification system based on industry is available on the talk is in the DCC 5 conference as well, and this is what they're trying to do. Uh, to develop a PDF A3 as use case present themselves already. This was something which was already approved by their quality manager. And coming to NPL India, we have these formal survey underway. However, through discussions held with NPL customer interface department, the general sentiment here is to have electronic calibration certificate like the PDF version rather than the digital calibration certificate. There is an interest towards increased document security and better turnaround time. That is what very similar to the past previous five NMI's engagement as well. Internal stakeholders, we want to keep a tab on what is happening in this in the field, and how the PCB DCC schema implementation we can utilize it for our calibration certificate. Right now, the focus is on XML and PDF A3 DCCs with in-house development using open source technologies for few parameters. We also want to have this incremental approach towards delivering digital products to our customer. We are focusing on to development of a customer interface portal and to have these awareness programs for both internal and external stakeholders. The path ahead for us is to conduct internal trials and evaluations on DCC and to find out the actual needs, whether a PDF A3 with embedded raw data is sufficient for the near future. And we have created this object-oriented model for DCC. And again, this talk is available in DCC 5 conference. So the major lessons and viewpoints from APMP stakeholders' viewpoint is that NMIs can push, but pull from stakeholders is critical for DCC to be a success. DCC, we see that it is a future, but it needs much more. So if there is no direct benefit that the stakeholders see that DCC brings to them, if we could have some early DCC adopter success stories, which Shana will present later in this part of the workshop, that can address this. And rather than getting the raw data with the certificate, stakeholders are more interested in getting the secure digital requirement, which digital document, which won't require them to make a lot of changes at the individual organizational level receiving it. The DCC schema is still not harmonized and standardized. And that's something that at Forum MT level, under the leadership of Dr. Martin Kowal, we are working on to this harmonization of the DCC schema, which may take some time. And what will be the, give them a business model which shows how this digital calibration certificate is helpful for them, and then things will fall in line. Because they have these concern that will it require continuous reengineering of code or systems developed for the implementation of DCC, or how DCC will integrate with the existing system, or how DCC will cater to the national and international regulations. So this DCC harmonization that is happening at Forum MD level, it's is working more on to what can be the mandatory fees that can be harmonized, and then for the national level and institutional level, we can always have these are like the way NIMT has proposed their schema for the national level. And then if particular organization wants to have some changes, then they can demonstrate, they can have it for the organizational level. But the international level schema has to be same or similar. So these DCC value drivers are how easy it is to generate, and how much level of effort is required from from the staff in the organization. If it is very secure and trusted, there are many takers for this technology. How transmission of this calibration certificate happens, and is the process secure and automated? And then is it machine and human readable both ways? And what are the open standards? If so this technology, calibration certificate technology, is very much open and it does not prevent vendor technology login, but it does need to have the facilitation from standards either through design or configuration. It should be easily accessible. There has to be longevity and preservation, and then extensibility where design allow for these type of flexibility to address jurisdiction differences and future industrial changes. And if there could be a middleware to extend the DCC solution to other systems within the organization. So with this, I thank you and I'm open for questions.
Thank you. Thank you, Dr. Angelique. We will step have time. If anyone have some question or discussion, you can please feel free to unmute yourself, the phone, or maybe you type in the chat box. I will read it. Anyone have some question? No, not yet.
Not yet.
Maybe during this time, I have some question that from the viewpoint from the APMP stakeholder. Which one is what do you think if which one is the first one you will try for that because you have that adopt the DCC or maybe try to push some certificate. Which one is will be the first strategic or the first one that for the group can push that?
Uh, if I've understood your question correctly, you are asking like which approach is better
Yes,
if you
yes,
want
yes.
to go for digital
Yes, for
calibration
the
certificate.
from that your presentation about that the viewpoint from APMP stakeholder.
Stakeholders. So
Yes.
the viewpoint from the APMP stakeholders is that we do not have a very good pull from the external stakeholders.
Mm-hmm.
So the industries or the customers, they are not very much right now interested for that machine readable data.
Mm-hmm.
But they see that this will be the requirement in future. So for internal stakeholders, this is more about how internally we can, in an incremental way, get ready for this future, which our external stakeholders will be demanding. So I would say that internally within NMIs, we have to keep ourselves abreast of what is happening in this domain and how we can develop those skills so that in near future when the customers demand and uh, this is an example from NIMT, they have given that facility for their users to actually start seeing what how it can be helpful for them. So
Mm-hmm.
these type of approach we can all go ahead with.
Yes. Thank you. And we have that the question from the chat box. Could you please explain a little more about the upcoming scheme harmonization in brief?
Ahmed, there is a group, a ad hoc task group that Wan Ho Chao discussed yesterday, that is on DCC and DRMC harmonization. So that's in the forum, CIPM Forum MD, and where we have representatives from different organizations who are trying to find out, starting from what can be we are starting from terminologies right now, that what terminology can be used for in order to adhere to 17025 mandatory guidelines. And then in the next part we may be developing or working with the semantics group to have ontologies also in place for this. So there is a layered architecture that has been proposed for schema harmonization, but we are at a very first step where we want to find out what can be the terminologies that can be harmonized and can be put up for discussion and feedback.
Thank you. Any more questions? If don't have any more question, thank you. Thank you very much for Dr. Anjali for your presentation. Ah,
Shana has a question.
yes. Have question.
Hi, Shana.
Concerning, yes, I will read for you that. Concerning the external stakeholder who participate in the survey, could you please give an insight from which industry domains they were from? And to which extent likely automate process based on that stakeholder gave their feedback.
Hi, Shana. We do not have this sort of stakeholder identification as far as I'm aware. But as you could see from NMI Australia's presentation, they identified those stakeholders as like, so each of these NMIs, they identified their stakeholder in a very different manner. So when it came to NMI Australia, they wanted to identify their stakeholders who are internal or they're small labs or the customers who are very much interested. They're very security conscious about the document that is being received and the large industries as well. Then another one from Korea, they had this perspective from like the organizations or lab which are issuing the certificate and the one who are receiving the certificate. So there was no as such this segregation of stakeholders uh, that we can give you for the domains they are from, rather than they were more from the perspective either internal or external stakeholders or the large lab or small labs or calibration labs and the details and especially and then from NIMT also they took that. So this stakeholder the type of stakeholder that you want to understand, that the domain they are from or how till what extent they are working onto the automated process, that's not quite available in this study. I hope
Thank
I've answered your question.
Mhm. And I have another question. Thank you for your presentation. Could you briefly elaborate on autonomous machine-based quality infrastructure and its relation to DCC? Just give a general overview of its mechanism. Thank you.
That's Thank you, Shana. So I'm not very sure about this autonomous machine-based quality infrastructure. But what I see in future is that if you have a digital calibration certificate and you have these values that comes in digital calibration certificate as per and they are machine readable. So they are automatically integrated into your system where you have suppose I'm making vernier calipers or I'm having these steel rods that I'm making and I want to identify the length and the diameter of these rods which is in the industry. And if I have these measurement instruments, I automatically measure. There are instruments from Fluke. I have seen them that you do this IA code and you can measure that length or the diameter of those instruments automatically. And once you have done that, you can actually automatically compare whether these dimensions, like the length or the diameter, are in in range with what is the demand from the calibration certificate, like including the uncertainty and including the tolerance that you have for that particular order of the product. So integrating it from your calibration certificate, then going to the even to the auditor who can see that okay, this is the valid one. Going to the industry, they can see that okay, what is the uncertainty, where is the traceability, what are the units included, because if this is measuring it in millimeter or something and the calibration certificate says that it has to be this much meter with this much of uncertainty, there has to be conversion. So there will be there will be lot and lot that will be required once it comes to the digital quality infrastructure. And I could see DCC as one of the very important pillars that will help in this machine-based quality infrastructure. Oh, I have quite few questions now.
Yes, maybe I think it will be the last question. Uh, yes, it said that how is digital
Um,
signature validation handled across border, especially for certificate exchange between NMI and industry? And will the scheme include metadata for audit trails or traceability future to support compliance needs?
uh, uh, the point of schema is that we need to have this metadata, which helps us in including, which helps us in doing this audit and traceability features. So that's the very important feature that the DCC is supposed to have. Now, coming to the digital signature validation, that's something which is a question mark, I would say, if it handles across borders, because um, the digital signature provider that I have, mostly if it is PKI and all those, it should be validated. But I had instances from few of the countries where their digital signature provider did not did not recognize what is being provided in this country. So that validation part, yes, that has to be seen, and I'm not very sure, but that's how one of your organizations in Indonesia itself, they are um, into the legal metrology part, or somewhere where they're using these blockchains to actually provide some validation to this examining or testing of these things that they're doing. But I'm not sure this digital signature validation, this can be handled between NMIs and industry nationally. Not an issue, but internationally, I'm not sure. I hope I've answered your question.
Okay, thank you. Thank you. I think that is have a lot of questions. Then because
Yeah,
of your presentation, it will be interesting.
thank you. Thank you.
Okay. Then thank you. I think thank you very much for Dr. Anjali for your presentation. And I think next we are pleased to welcome our second speaker. Uh, the second speaker is Dr. Nalin Chantawong. Dr. Nalin Chantawong is a group leader of Nanometrology Group in the Dimensional Metrology Department at NINTI and a member of Digital Transformation Center team, actively engaged in research. They focus on the transformation of metrology and the methodology of the digital transformation. Their work advance precision measurement techniques and integrate cutting-edge digital technology into the fields. With a strong passion for innovation and accuracy, Dr. Lin plays a visual role in shaping the future of metrology, ensuring it evolves alongside technological advancement. Their expertise helped industry maintain high standard of quality, precision, and reliability in an increasingly digital world. His topic today is automate accredit scope verification with DCC. Please join me in giving a warm welcome to Dr. Lin. It's over to you, Dr. Lin, please.
Thank you, Mr. Rarat, for your presentation. Okay, nice to meet you. My name is Narin Chanawong from National Institute of Metrology, Thailand. Okay, let me share my screen. Okay, is it work?
Yes, yes.
Yes.
Okay. Moment. Okay. Oh, sorry. Okay. Oh, we have a limited time, so I will focus on that. Okay. Hello, everyone. So today we were talking about the automation of laboratory audit using a DCC. So firstly, I introduce you first. So as an MT, as an NMI, so I think as another NMI, we also have the same job that we do a research service and collaboration and the knowledge transfer to uh, people and organization in your countries also. And the digital is one thing that we are focusing on because it's a trend of the world. So the digitalization is defined in NIMT 5-year operation from 2023 to 2027. And to support these activities, so we initiate the NIMT Digital Transformation Center that we call the DX to serve on this job. Uh, and the currently DX, NIMT DX, we have 8 members and that focus on digital metrology and automation. And we also have another very cooperation on regional and international and the knowledge transfer to government and private sector. I will go fast on this part because it's not a thing that we were focusing on. And we are the member of the forum MD that Dr. Wan Ho and Anjali also mentioned that on the harmonizing DCC and DIMC and the data quality and fair principle on metrology and the task group of AI. And yeah, we will join on the sensor network too. And also the IMICO, we a member of TC6 digitalization. And in the regional, we also the member of the XFG Digital Transformation Focus Group. Okay, that's the brief introduction. And that's how we do it and why we do it. So let's focus on. So you saw this already yesterday by Dr. Jaria. Uh, so this is a concept of the flow on the data. Because when we're talking about the calibrations, it's still about the machine. It's about the physical machine that you have to bring it to compare it. Yeah, it's still an artifact. It's a piece. It's a physical thing. But how to be a digital life on this? So therefore, what is to be a digital? It's the data. It's the data and information that should be digital and it's transferred to the flow. So as Dr. Cheriya mentioned yesterday, so we have activity on the calibration here. We have your UUC and you have a standard here with a certificate. And yeah, you can use something that you get the data from data transfer or you use the OCR that you got the measurement results. You got the measurement results. And here is the data. And here is the thing that will flow digitally. And the data will flow to the thing that we call the DCC web portal. This thing we create as a DCC generator to cover the weakness on the programming. Because yeah, the XML is good, it's very useful for machine, but it's not friendly for the human to understand it. And so the DCC web portal will solve these problems. And then it go to somewhere that we store it, that we call the EMTS, to store the file. And it should be possibility to call the file to instrument if the instrument is support in future. That is the way of the data process flow. And the thing that we are focusing on, we're focusing on their web portal first. The idea is you have a certificate. Yes. So when you have a certificate, how can you know that it's accredited? Or how can you know that it's traceable? If a paper certificate, how you will know that? Yeah, because we have a CIP MMIA to support it. And the ILAC P10 said with you, okay, if the certificate have a CIF logo on the certificate, it means it's accredited and the measurement traceability is can traceable to SI unit by ILAC P10. And for that, only for the CIPMMA is only for the NMI or the DI that can publish your competence on the KCDB website. But for the another laboratories, mostly you are using a 17025, and the 17025 we have a logo on the accreditation body, depend on your country, right? With the ILAC MRA logo. So it may come only once or may come both together, is also okay. But yeah, this one is support both on NMI and accredited body. This is the way how paper works. But for the digital certificate or the DCC, how do we know that? But yeah, the PTB also have a ref type for this specific kind of mask. We call the calibration mask as a one of ref type. And the idea of our team is it possible that because it's data, it's possible that data can flow and we can check it instantly on that tab. Okay, to come to this idea, then we do a DCC on our own schema. Yeah, our own schema is an MT DCC schema version is 1.1. So it's based on the PTB XML DCC version 3.2.1 with some modification that Dr. Julia also says on yesterday. And the modification is mainly focused on the measurement result part to keep some additional information that will allow us to use for a verify on accreditation score. And this schema is also public on the EDA website. That is a regulator of Thai. So therefore, the schema is okay to use in Thailand. And the structure is also the same as Dr. Ria said yesterday. I will skip it. And what exactly we construct in the schema? Okay, so let's talk about the results. On the administrative data, it's the same. Signature, we also the same. We try to make it common as much as possible. But for the results, we try to do something different. In the first, we have additional one thing that we call the service code. A service code is like your service ID or service line that you can provide to your customer. And it will be as an identifier to you to know that what is the measurement that you are measuring. So in the results that on the measurement one, you will have a one service code to accompany with. And in one measurement, for example, we say in a scale, for example, a ruler, easy one. A ruler, okay. The measurement of the ruler is the length, yes. But the point on the artifact is not only one point. It's maybe, for example, a meter of rulers. So you can have a point on 100, 200, 300, 400. But it's also the same measurement. Then we group it to the one group on the one service code. And on the measurement two, also have another group with another service code, and so on and so on. So it's go on the sideway if you have more results or more measurements. And How do we check it? Okay, therefore, in our schema, we have a service code within measurement results and how to link it to another database. Therefore, in our service playlist, we call the playlist, yes, sorry, it have a service code also. And also we try to create our own dummy KCDB database on this experiment. And it have a service code inside that KCDB database. And we create, for the experiment, accreditation body database for a service code to accompany with. Therefore, a service code will do as a primary ID on every database. Therefore, it can link data to the database and can recall a data on the database too. And we apply it on our web portal. So our web portal is a website that it can generate the DCC both on the XML and the PDF A3 with XML attaches and also cryptographic signatures. And another part is also can verification with an NIMT schema, both on the XML and also the PDF A3 also. Currently, it can verify on the NIMT schema. And the signature, about the signature, will do it in next, able to do it in next year. Now we are developing. So how does it work? So as you saw in yesterday for briefly, so we have a part on a public user that you can go to the website and just typing in the data, and it can generate the XML with NIMT schema here easily. That's for the public user side. But for NIMT staff, NIMT staff will more detail on that. We have a login page to know who using, and they can create the DCC using a measurement result is with tie-in or using a template also. And the system will call data from administrative data to get your customer detail and also the artifact detail. For example, artifact name, model, serial number, or something like that. And the system will create both of PDF A3 and XML. And on the PDF, when we say about the DCC, it's okay, it's XML is a one template, one pattern, that's all. But for the human, the PDF A3 is have different template. It depends on your scope of accreditation on that service line or the service code. And the system will be able to select the template by recall data from database that from KCB or the accreditation body database to decision that okay which template that we are using. And we have a cryptographic signature to sign over the PDF A3. Okay, let's come to the point. So in NIMT, currently for calibration, actually we have more than that. But for calibration, we have three types of certificate that we are using now as a paper. The first is a normal one. Yeah, nothing here. The second one is 17025. We have accreditation body logo here. And the third one is CIPM MIA that the measurement scope on that is public on the KCDB. Therefore, it depends on, as you know, many things. The artifact, the measurand, the range, and the sanctity. So, therefore, it have a parameter that you have to consider it here. And currently, we can do it on one instrument, one data, and one instrument with many data. Yeah, it's okay. But for the more complexity, like, okay, one instrument is have a data with a picture, for example, a graphical or the photo, something like that, it's not support yet. And for the complex data results, it's not support yet. And to report the result as uncertainty as an equation is also not support yet. Okay, how it works. So when you got the result, of course, you have a measurement result and the uncertainty that you will type on your certificate. This come to here to this uh, system. The system will go to see in the KCDB. So they have a service code, right? A service code. So that service code that we give them is we go to look over KCDB. Is it exist or not? If yes, yes, it existed. So we go to the range that you use the measurement results to compare it, right? Use the range. So is we in the range or not? If yes, go to compare the uncertainty. So as accredited uncertainty, it should not below than that you state in your accreditation body or your KCDB website. If it's lower, so adjustment. If it's higher, so okay, you got a CIBM MIA template. But if the data come and we go to see the service code in KCDB and says no, don't have it, so it's go to accreditation body database. Or even you have a service code in KCDB, but the range is larger or maybe smaller than your accreditation scope. It's also go to the second row on the accreditation body database. The accreditation body database loop is also do the same things. See the existing on the service code in the database. If yes, see the range is in between max or min. Yes. So compare the uncertainty. If all yes, it means it will be accurate template will be used. And if no for the both of KCDB and declaration body database, it will go to a normal certificate as an empty type. So therefore, the system is able to select the template for you. So this one is not served for the machine, it's served for the human. They will, okay, this will have a logo, this will not have a logo. We know that. Yeah, it will solve this problem. And yeah, to check is it possible or not, we try to make a proof of concept program to validate a logical process that I mentioned in previous slide. And yeah, it's possible to make a decision on the value and the uncertainty that we typing in. Okay, here is, for example, the website. You can see it's go log in and we see the work here and you can import the data. The template is the Excel template that we provided. The data will go to the website and you can have another additional information that you can typing in. Here the results that will import from the Excel template. And so when we go next, it will be generate it will generate the PDF preview on that, both with XML, DCC, accompanied with this PFA tool. Okay, here is the part out on the website. This part will create 5. So, and how to use it? Yeah, you got the result, you got the DCC, and one additional application is on that. We'll focus on the EMTS. EMTS is Equipment Management and Tracking System. So the idea of EMTS is like like a Google Space, Google Drive that allow you to use uh, space on that, and you can create an organization on that to manage the document. And the structure of organization and hierarchy is have relate on this system. For example, if you are the people in group 1.1.1 and you have equipment and person in here, so the person in group 1.1.1 will allow to see the information on these two machine only. They cannot go to see the information on the machine in another group or the higher group. But the people in the group 1.1 here, they allow to see the information on equipment of the both subgroup, for example. That's its concept. Uh, yeah, and the thing that we are doing, so the record in here, so it have can record on on the calibration certificate, on the maintenance record, and so on. And the thing that I will show you is like here. So we modify the EMTS to support the DCC. For example, is a equipment that the new one that you just got your instrument and the file. Just upload the file. It will fill out data that extract from a DCC. Yeah, to do it, yes, of course, it use uh, ability of interoperability, but it should be a lot of things that we have to do more. Let's show the idea of usable of a DCC in here. Okay. And what is the next? Oh, it seems to be a very good uh, working things, but yeah, it have a lot of things to do more. One thing that in our idea is to reverse the process. So the process is to that I talk with you is about how to create a DCC. So, but when we got a DCC already with on your hand, how do we know that is accredited or not? Yeah, it should be reversal, and it will be developed to support on the both of EMT and the NIMT web portal, passing through the automated scope verification and link it with the database on the KCDB and the accreditation body and NIMT. Yeah, and this will show your ability to show to recheck on the scope of accreditation instantly. Okay. So it's the end of my talk. So it seems like okay, we developed an automated accreditation scope verification system and to validate the measurement result by in the DCC. And to do that, the DCC is have modified to adding some additional data to support the accreditation scope of verification. And to do that, moreover, we have to do a database. Like specifically is a KCV database and accreditation body database to operate on the system. Uh, it seems like working, but another thing to do is a lot of things because when we try to do it, we see many points that we can improve that. Firstly, is on the DDC that accommodate with more complex results. For example, we say the electrical power. what is your measurement? Your measurement is the power, but it depends on the frequency. It depends on the current. It depends on the voltage. But it's not a measurement, but it accompanied with your measurement too. So how do we make it on that DCC schema? And to make it on the DCC schema, we also, because we are also one of the member on the harmonizing DCC, so we are waiting for to make a world harmonizing in the first step first, and then we will do adjust once with all of this. And the future upgrade will also, that's the thing that I just talked about to validate, to revalidate the accreditation score. And the final thing that we can see that the database, for example, the accreditation body database and the KCD database, actually it should be not belong to us. It should belong to accreditation body. It should belong to the CIPM or something or somebody, some regulator like that. And we will collaborate with the NIMT accreditation body to implement, to make it more communicate between our collaboration between instrument, between institute to make this system work, and also to make it more support on the secondary laboratories that can create the DCC and also can do verification on that scope of accreditation too. Okay, that's all of my side. Sorry to make a lot more time. Thank you for your attention.
Thank you, Dr. Norin. We have time for the question. Any question from the chat box or from the floor? No? Yes, it have the question, one question. In the chat box. What specific further technology make a DCC certificate machine readable? For example, does it really QR code, barcode, chips, or another digital format?
Actually, the it depends on the, how can I say, the type of the DCC that we are using. So mostly we are use the XML5. So the PDB is originated on that XML, and we put the information in the XML. So XML is a text file. It's a text file that every machine can open it, but the structure on the XML that will let the machine know what is what. And the structure is called a schema. And the schema currently is not harmonizing all over the world. So it's the next step that all of the NMI that we have to work together to create harmonizing on this schema. And if we can do that, that means certificate from anywhere will be can using to in another NMI also. So basically it's like that concept.
Okay. And the next question is, can the same service have different can the same service is too many questions. Can the same service have can the same service have different service code from different organizations? How to deal with this issue?
Yeah, this so that means you have to, how can I say, the you have to identify, you have to have an identifier on that. For example, if we go, if you go look on that one, we have a, how can I say, we have the, as that we talking on the a service laboratory that, that question is from Angelique. Okay, It's same as that we talking on the forum and in the beginning of this week. Uh, so in Thailand, in every company, they have something that we call a tax ID, right? So the tax ID will identify the individual company or individual laboratories.
If I'm not mistaken, the service code are helping us to identify the measurement.
Yeah, but the information in administrative data
Mhm.
can identify the laboratories.
Yes, I understand that, but
Mhm,
my point has been that even if we have we can have as many PIDs as we want. Like
mhm,
suppose I remain the same, but I can have n number of email IDs, and those n number of email IDs are very unique, but I
mhm,
remain the same. Similarly, if
mhm.
I have a service which I am recognizing it as a difference, like I recognize it differently in comparison to what other is organizing it as service code. They give a different service code for the same service type. Then how we can address this?
Yeah. Actually,
Can I jump in?
Yeah, yeah,
yeah.
yeah.
I think that Angelia would like to help.
Uh,
Okay.
The service code is administrative data, as Dr. Narine said. So it's the information in our case, if it's NIMT certificate, it's our ID. We were not going to read any other certificate issued by other institute for
Okay.
this information because it's the
Yeah, yeah.
it's
That
the
makes sense.
generator information.
That
And
makes
and
sense.
and another point that I would like to add for the first question, it's really important for everyone to aware that DCC is like information envelope. It's contain information. It's not going to be any machine not going to read it unless you tell machine to read it. It's not a machine itself. It's just envelope of information. So in order to make it readable, I mean, we make it readable, but in order for machine to read, you will need to send command to the machine to read this envelope. And with the XML format, the machine will know which information is which. Okay.
Okay. Uh, if that answer your question, then we move to the next question. The next question is about that what tools or method have you found work best for turning measurement data from handwriting handwritten worksheet into a digital form, and how accurate and efficient were they?
Yeah. If you talk
It's
about the
difficult.
handwriting worksheet, it's not
Mhm.
that easy. Yeah, as you know that the technique that we can convert to from pictures or something else to the digital numbers, that mostly they are using the OCR. Uh, but the OCR itself is like you is like a photo hunter. That okay, if the photo is the same, then we know that this one is zero, this one is one, this one is two. But if you handwriting, so the I wrote two is mean different than you write two also. And this is a limitation on that OCR to use a handwriting on the worksheet of handwriting right now. And it may possible that if you create your worksheet, in my idea, if create a worksheet as the individual number, for example, uh, 12.21, you may 12.21 in each box, and then it will be easier to convert it to using your OCR to convert the number, some kind like that.
Okay, I
I'm not
think
sure that.
maybe Yes, maybe this is the last question for you. What do you think about including a QR code to verify the authenticity of the certificate through a platform managed by the laboratory?
Yeah, it's also possible to have a QR code, but the QR code is just a link to somewhere that you have to keep your file, and QR you just scan is just is how can I say, is only the address that you will go, but you have to have a space to keep the file too. Actually, that is the answer. That is why that we create the EMTS. The EMTS actually itself is also create the QR code that you scan and will go to see the file in EMTS. But however, if you just create a share link on for example on the cloud service, so that means they can access easily to see your file if you go to publicly. So how about the security on the file? How about the security on the information of that file? Therefore, the EMTS is also have that's why we create as an organization in the EMTS and have a hierarchy on that with login required to support on that information. But yes, it have about the QR code is also, but the QR code is only the like a number or the identifier to see the file.
I think it should be the last question, but then you can explain in short that. Could you please describe about the digital signature mechanism on DCC?
Okay. Briefly, is actually they have an organization that support on the signature that we call the W3 organization. The W3 organization is easier is the organization that control the website, control the protocol on the website. And then they have a protocol on the digital signature on that, and we do comply with their W3 protocol that they are provided.
Okay, thank you. Your presentation is very interesting for everyone, then have a lot of questions too.
Thank
But
you.
thank you, Dr. Lin. And we move on to the last speaker, the final speaker, Dr. Chana. Dr. Chana, she has kindly provided a pre-recorded presentation. And the presentation will talk about how DCC help industry. And I will be explain some short bio for her because she already present some bio a little bit in her presentation. Dr. Chana Chohol worked at the PTB German National Metrology Institute and a background in mechanical engineering. And now she will be the specialist in digital transformation and digital certificate. She worked at the head of working group for focusing on DCC development member of national and international committee. And I think let's give a warm visual welcome to Dr. Chana.
Dear colleagues, thanks a lot for this opportunity of being able to present to you the Digital Calibration Certificate case study number 2 and to give you an insight how DCC can help industry and our customers. So before I start, as I'm unfortunately due to the time difference, I'm not able to be with you in presence, and I have made this recording thanks to the organizers that have made this possibility available to me. Just some brief words to my person. So my name is Shana Schönhals. I'm with PTB, the German National Metrology Institute. I have a background in mechanical engineering and a PhD in aeronautics and aerospace. And since 2020, I have specialized in digital transformation and more specific in digital certificates, and that will be the focus of my talk today. So I'm the head of the working group which is focusing on DCC development. I'm a member of different national and international committees of different levels, and I've been participating or leading projects that have contributed to the developments in this field, like the SmartCom, the GENIMAC 2 project, and currently the CABOREC Metrology for Digital Transformation International Cooperation Project. So let's start with the DCC, which is our focus today. So the implementation of DCCs and automated processes is something that we envisage. And here on the right-hand side, you see the calibration pyramid, where we had at the top level the National Metrology Institute, below that then the accredited calibration laboratories, and then the in-factory calibration labs which are using calibrations in production, and in the end we have the product which our customers of course would like to have certified according to the requirements of, for example, ISO 9001. And about the DCC, I've already had some talks on this today. So just a brief summary, the aim is to have a standardized data format to transfer the calibration information. It is to enable machine-to-machine communication, to enable also the digital traceability chain, which is about transferring the uncertainty through the traceability chain down to the product, and to enable, of course, automated processing of the calibration information in a legally compliant manner, so everybody can really rely on this. The expected benefits is, of course, for the end users to have less administrative work, have in the last consequence also 0 errors in data transmission, and of course that should and is expected to result in significant cost savings, and we'll come to that later, building on a very concrete example. So in Germany, we have all together, if you calculate all that numbers depicted in red here on this picture, we have more than 55 million calibrations per year when it comes down to the project. So from this, you can imagine if we could use the DCC only on a portion of that, how that would scale up. So the DCC, a very brief recap and introduction also to the DCC XML schema as used by us and also our customers. So it is a very standardized XML-based exchange format using the XML in extended markup language. The schema has been developed with international partners. You see here we have contributions from the European community, but also from the APMP community and the SIM community. And also we included a lot of industry partners, especially in those projects that I presented on the very first slide. So it enables automated validation of the issued certificates, and it also enables digital signatures, which is very important also for our customers. And for this, I would also like to thank and to give credits to my colleagues. You see here on the slide, with Klaus Pickinger from Boehringer Ingelheim, who is indeed a DCC customer using the DCC currently in this project called DCC in production mode, and Christian Sander from Testo, who is a DCC enthusiast and really forwards the DCC development a lot within Testo and also within the DKD harmonization standardization groups. So you see here in this project we have a team, which you will see just in a minute. So Boehringer Ingelheim, of course, is in the middle. It's about them. They are the customer, and it is the largest German pharma company. So they produce on a very global scale. You will see it later, lots of pharma products, and they are really keen to automate their calibration processes, as they have already automated a lot of their production sites. So Testo is one of the largest calibration service providers, and Anders & Hauser is one of major sensor and equipment manufacturers, also operating worldwide. Then we have Siemens, who participates in the role of factory or plant planning and management equipment provider. And we have BMX, who is a worldwide leading company for system integration and measurement equipment management software. And the BTB is here in an advisory role and provides the framework of the DCC as well as the templates. And we have here some processes like the DCC and also DCR. I will come to that a little bit later. The part calibrations and specification and classification that is being looked upon in this project. But let's, before we look to the digital future, let's take a look at the past, or even also at the present. And what we see here is an analog paper-based calibration certificate, which is already in PDF format. And this is the most common form for transferring calibration results for Testo, this calibration lab or calibration service provider today. So this is really the calibration service provider's view. And here you see first the accreditation symbol, which on the top right of the first page, which means that the calibration has been carried out as part of the accreditation that the laboratory holds. The certificate therefore provides proof that the measurement results are metrologically traceable. And this traceability is the most important characteristic of a calibration for the metrology community. And then if we look further down, we see the conformity statement on the page. In this case, the device has passed the calibration, and this conformity statement is often the decisive feature of the customers, for the end users of the test equipment, to use the devices again after the calibration. So this is the whole purpose of the calibration indeed. And if we scroll further, we'll find a clear presentation of the measurement results in a table. So here is the deviation, measurement deviation from the reference, and the very important measurement uncertainty, which you probably find in every calibration certificate. And with these measurement results, we have all the information we need to correct the display of the measuring device in use. With the information in the measurement uncertainty and the deviation, we are also able to calculate an uncertainty for the application itself. And then, even if we have several calibration certificates for this device over time, we also have the information to carry out statistical analysis, for example, to define dynamic calibration intervals, to calculate a drift, and also to use or even correct it. So, and you can do many, many more things with this if you are able to use the measurement results. But unfortunately, we know from many customers that these measurement results are only actually utilized in a very few cases. As a result, the added value in the data is rarely used in the industry, or you can even say it is lost. Because, why actually? And if you ask yourself why the calibration results are rarely used, actively used, so you may also come across the answers which I would like to present to you just a few slides later. So what are actually the expectations regarding the calibration certificate? So customers want to reuse the analog calibration data, which they actually get from the service providers. But at the moment, it's proceeded like this. It's just archive the data and it's done. And you need to transfer, manual data transfer, and hope it will be fine, so without any errors. So what you actually end up now at the moment is to archive and do it yourself, which is actually not what we really want. And the simple answer to this rather difficult question that I posed before is that calibration certificates are not easily to understand for non-specialists. So what the industry requirements really are is to easily understand and interpret calibration data, but the current information is that too much information is presented in a rather confusing manner sometimes. So here in this table it's maybe not the case, but you will see it might be in different other cases. And interpreting the data in a correct way requires expertise. And again, what comes in next, the calibration certificates from different laboratories also vary too much in their presentation. So here you see an example from a weight key comparison. And this is only about reporting of ambient conditions. And you see this, all the green squares come from different participants from different laboratories, and they have all said something about the temperature, humidity, and pressure, and they have all presented it in a very different way. So even that is how you get the results, and this is not easy to find your way around. The most important point is, however, that using the data requires a lot of manual data transfer from the paper-based calibration certificate. And I would even go even further, though it doesn't matter if it's paper or PDF, you will always get that data in that form. So currently, which is the process, the data is transfer is done manually. It is very time-consuming and also error-prone. And what comes in next? Validating such a process of manual data transfer, for example, in the pharmaceutical industry, where we have this example from, is virtually impossible. This means that even from an industrial perspective, we see a very strong need for a new technology for the exchange of calibration results from calibration certificates. So here we see it, today's requirements and situation. So what we want to do is to reuse the digital calibration data. So we want to have standard formats and standardized content representation. We want to use error-free and unambiguous data identification, and we also want to make use of added value. So we want to optimize the calibration intervals. We want to monitor the devices. And this is actually the added value behind that. So we need a technology that can be harmonized across all the measured variables so that calibration laboratories can present their results in a standardized way. And also the customers can interpret that unambiguously by machine and automated processes. So the technology must be also globally recognized, available, and harmonizable. And many customers are actually globally operating companies, so they are active in Europe and beyond. So there's no need for national standalone solutions. And the good thing is, of course, that there is such a solution. And when you see here, you have the possibility to have an authenticated with a digital signatures, encrypted and signed transmission of uniformly machine-interpreted calibrations according to a fixed scheme, which is then the calibration certificate. And here you see the logo by Testo. They are already able to use and produce the information also in a DCC-like way. And then let's have a look how they do it, because they have already implemented that process. So they can see here the information items of the DCC. On the left-hand side, you see all the items that are represented according to the object under calibration. Here you see the analog information. On the right-hand side, you see an excerpt from an XML file, and you see everything that is in blue that has to be filled out, and everything which is in bold and in black that are actually the items that are filled in by the calibration laboratory during the process. And you see here the object, the manufacturer, the type, the serial number, the equipment number, and also the test equipment number, which you will all find here. And there is everywhere a place in the calibration certificate, the digital calibration certificate, to fit that information in. And when we go beyond that administrative part, also the measurement results are initialized in the C result elements, and there you can find in a similar way than the DCC lists that can be filled then piece by piece. So you have the measuring results, you have the reference results, you have the measured value of the device on the test, or the unit on the test, and here you have the deviation, which we have seen already in the analog example, and here, of course, the uncertainty that we need. And you can either go then by the XML structure to find the values to interpret them, or you can also use the harmonized ref types. And the nice thing is that no matter which measured variable, because those ref types, those marks are actually always the same. Now let's have a look at the customer's point of view, the Boehringer pharmaceutical company, which we have here as a customer. So you see, they are really operating globally, and they are production sites all over the world. They have also quality management sites. So it's a lot easier for them to use the same format no matter where they operate. And what about the facts about their production? So according to the calibrations processes, they have 150,000 calibrations per year on a global scale. They have about 50 service providers who perform more than half of their calibrations. And what is a situation which makes it a little bit tricky also for them, that 20% of the instruments sent to the external service providers, so they cannot be performed at BI site and within the calibration system. So they receive all the documentation only on paper, or if they're lucky, then on PDF. And they have very high requirements. They have 30-year record retention time for this quality relevant documents. So this is really a lot. And they have said, well, DCC could be a way for us to go, because if you look at their calibration data traffic, you see it's not only these 3 partners they operate with that you've seen on one of the very first slides. They have a lot of more partners, and this is only an excerpt from this. So you have a lot of different partners, you have a lot of processes, and you have a lot of arrowheads in combination of very different variety of business models. And to have an interface with for any of them on an individual basis would be actually impossible. And that they have decided to initiate this industrial project, which they call production mode, DCC production mode. It is subdivided in 3 different phases of parts. And part 1 is about automatic data transfer with the DCC between the manufacturer, the service provider, and the Boehringer Ingelheim to put it in their calibration system, which is actually at the moment ongoing and already almost finalized. Then a little bit in parallel is starting about part 2. It's about automatic data transfer of a digital calibration request, the DCR, between Boehringer Ingelheim and the service provider for regular calibration, so the calibration which they do on a regular basis for all their devices. And then they have part 3, the DCC exchange and application within the Asset Administration Shell, AAS, which is a very important emerging standard for data exchange within industrial applications, also including digital product passports. Maybe I've heard in Europe that will become mandatory from next year for several types of products, but over the years, virtually for all products produced here. And also utilizing data spaces, so we come more from a document-driven exchange to a data-driven exchange. And for this, of course, you can imagine a standardized format which can be interpreted automatically is really vital. So let's have a closer look at the sample workflow for sensor calibration that has been implemented in that project. You see here at step 1, Boehringer Ingelheim issues a DCR as a customer. The Testo calibration lab is performance calibration, creates a DCC, transfers to DCC, and at Beringer side, we have BMX, who imports the DCC and manages the data transfer. And Beringer Ingelheim, as a customer, has now all data available to operate the sensor in production. And if you like, there is also a very concrete example for a probe, actually a temperature probe that we have chosen for this project. So here in the DCR, you have all the instructions, everything, the measuring points, identification that have to be transferred to the calibration lab. They do what they need to do, and they create the DCC with digital seals, and they provide the DCC in whichever way it is useful to the customer. Then here automated import of data can be done, and for example, some corrections can be already applied when the instrument is used really in the pharma production plant. So we have asked our customers, and that's what they have really, they can confirm the advantages for the industry of using the DCC. It is a universal and global standard, and it's regardless of company size. It's extremely high time savings in data transfer that can really confirm this. Manual steps and time-consuming processes for data backup are eliminated. They can have their highly qualified employees focusing on their real know-how, doing their job, not transferring data from paper to databases. Avoidance of manual and error-prone copy-paste steps, and a very high security regarding the validity of the data. And now if you ask yourself, what are actually the savings? Well, this is the estimate that they can already give you now. So per every single calibration, you can save up to 45 minutes because of this really potentially error-prone process with the 4 eyes principle, with the sometimes quite complex structure of the data that you need to interpret. You can save 45 minutes of time for each calibration. Now let's do some calculations. So DCC numbers for this very simple use case, which we have here. So remember, 150,000 calibrations per year for BI, 45 minutes time saving per calibrations, and only this administrative part and data transfer part. So here you can save, depends on how you calculate, 2 to 3 million euro of potential saving for one company for each year. So this is the numbers that they can be confirmed by our customers, but they can be also further use cases. So for example, really using this data history, that what I've been talking about before, you can potentially extend the calibration intervals from 1 to 2 years. So that would also result in 50% of cost reduction. So you have, depending on which numbers you say, between 200 or 300 euro per the cost of a calibration. So if you can reduce that, so expected yearly savings would be several more millions of euros for each customer who would implement this DCC, and that would pretty soon result in return of investment for the customers. And this is actually the reason why our DCC production mode team says DCC is the game changer. Here you see the whole project team gathered together, and you see how enthusiastic they are with the temperature probe in their hands and transferring that to a digital calibration certificate information. So all of them are really enthusiastic about that and are happy to bring this into life and into real production processes. With this, I would like to end my presentation, and I'm looking forward to questions that you might have. So I will be here with you for the Q&A session. Thank you and bye.
Thank you, Dr. Chana. And like her said that she's live in Zoom with us. If anyone have some question, you can ask. She will be happy to take the question. Anyone have some question?
May I say my question?
Yes.
My question is about for example, you generate the DCC file, and after this process, next step will be prediction, and this DCC files and more data maybe for the prediction, some data analyze do you use? Yeah.
So if I may just recapitulate your question, your question is about once we have the data which is stored in a digital form, so for which that data is going to be used. Is that right?
Yes. What is it next step after the DCC file? That analyzing or in another? I want to know this. Yeah.
Okay. So first of all, yes, this is one possible use. This is correct. So you can analyze data. You can analyze the historical data which you have available for your sensors or your device under test. So for example, when you have this temperature sensor that you've seen in my presentation, they have this calibration interval, and they have to recalibrate that, and they can see how it behaves during the time. And then you can directly see if it's still good, or if you can even extend the calibration interval. So this is one of the possible benefits that you can draw from it. But you can also do the direct use of this calibration data that you have. So for example, which I have shown also in one of the slides with this process, when you use this sensor in the production of pharmaceutical products, you can directly use the corrections that you get. You have these deviations from the reference points. And when you see, okay, for this sensor, for exactly this single sensor, you can already use the data you have available to correct the readings. And this is which you can already, without any data analysis or so on, just take the data and use it directly in your production process, which is also a huge benefit for the customers. So it's like twofold.
Yes.
I hope that answers it.
Thank you. I understand. And this your answer is very informative for me. And my next question is about after the authorization certificate. For example, what kind of types do you use? For example, digital signature or another format for the approving calibration stuff, and also verifier.
Okay. So first of all, yes, the signature or sealing of the calibration certificate is done during the production process. It is not a mandatory thing. There is no such thing that says in the ISO 17025 standard that you have to sign or seal such a document. But however, for every electronic document, it is very good to do it. So it is not mandatory by the standard, but by the process, it should always be done. And in our in Germany, we have like also in NIMT, there is this accreditation authority that gives to the accredited labs this calibration or this mark that you've seen also on the PDF certificates, and you've seen also in Narin's presentation, that they say, okay, this laboratory is accredited for doing this calibrations. They are competent. And this is likewise transferred to the electronic document with the e-signature. So there is this electronic signature process, which the the PKI is provided by the accreditation authority, and they can use it directly, this electronic seal, to prove also that they are accredited to provide this service. And for the personnel, so maybe this is what you mean, that the personnel who is performing the calibration is competent to do so. This is done by this accreditation process.
Okay, thank you. I understand.
Okay.
And I just saw that Anjali, that you raised your hand. Do you want to ask the question, or do you want me to read?
You can read. It's okay.
Yes, okay, I can read. Then I will read the first question first. That and how feasible in DCC adoption for small or medium-sized industry?
I think it depends. So we've seen a very nice presentation by Anjali this morning, or this in the beginning of the session, which showed very clearly that there are some concerns from some stakeholders. However, once the process is started and there are tools available, and it is actually quite an emerging landscape of libraries to use just to read the data out of the calibration certificate. So once there is quite an accepted standards, and I've mentioned already some standardization work. It has already been mentioned in the talks before this forum on digital transformation is very active on this. There are some regional and national groups that are working towards really high standardization of all the items stored in the DCC. So once that process is completely done, and we are actually nearing standardization, then there are also tools available which can be plug and play, put in the processes. So and there are also providers like BMAX who provide already some software which has DCC capabilities inside. So it is actually also something which a small or medium-sized company can adapt using that open standard. So there is no cost of using, no license cost using this resources, and then it is feasible. The work that is, of course, still there is to streamline your workflows. So the workflows, the data mapping, that has, of course, to be done by each company on their own, because that cannot be done by anyone else.
Okay, thank you. And the second question is it the NMI responsibility to make sure that our customer machine are able to read our DCC?
It is, of course, something that the NMI should have in mind when they issue some DCCs, that they speak to their customers, so to their direct customers, and they are able to interpret. So to ensure interoperability, to have a look. But I think it is a mutual responsibility. So also the people using it are in charge of making that happen. But of course, there is some dialogue involved.
Okay, thank you. And this question is from Anjali, that she said that what level of readiness was required for customer in terms of system integration and manpower for this case study? And the other question is about that. Also, in one of your slide, it says benefit of DCC is that it's a global standard. Can you please comment of this?
So first, I have maybe one clarifying question. What do you mean by level of readiness? So do you mean that their processes are already in some way digitalized, or what do you mean by level of readiness? Referring to what?
Yeah, I in one of your slides you showed those different certificates, no? So when we talk to each other, we have our own way. We have our own certificates. So what level of harmonization and readiness was required when when we are talking with Testo, then Siemens, then PTP. So how did that happen?
Okay, so thanks for clarifying that. Now I think I got the point. So there is this project which is running now for about 1 year, when those people are meeting together and discussing that in subgroups on quite, I would say, quite high level. For example, Klaus Fickinger, which I've shown the picture on the slide, is the head of calibrations global of whole Boehringer Ingelheim. So he is in charge of every calibration process. He, of course, does not do any calibrations, integrations himself, but he has the overview. And then and some of his stuff is involved in that project. And same also for the other people. So for each of the partners, there's 1 to 2 people involved in the project level, and then under them to some part of their working time, then there are some more people involved doing that integration. So the level of readiness, so we actually all agreed how it has to be done, and then there were some process steps to be agreed. So from which point we start, which measuring equipment we choose, how is the process of ordering a calibration. So this is not only about the DCC, but when it comes to the production level, then they have the whole process in mind. So this is actually something that is this integration part. So you have to do something, but you have tools for doing this. So for example, BMEX provides a system called BigCal, which they have installed in Boehringer Ingelheim, and then they just developed an extra feature for that, but they can reuse it in every other software which they have at other customer sites. So there is some effort involved, so you cannot deny that, but this is something which they say, okay, once we have this exchange format and we know what we want to exchange, that helps us. And referring to the second part of your questions, that a global standard, so this is actually something that we are all heading towards. So we have this XML, which has been discussed with a lot of partners. So we have had over the years, since I didn't show the timeline, but since 2017, we are discussing from partners, not only from Germany, not only from Europe, but really from all over the world, who told us their requirements and which we try to incorporate in this XML scheme. And we are now putting that in a discussion on the Forum MD level. So the XML scheme is like an instance where you have to agree how to exchange things with your customers. And maybe in some years' time, we will have more data-based exchange, not document-based exchange. So this is something where, what I mean when I say global level, global standards. So where that is not a written standard, but this is kind of de facto standard that we are now working upon. Okay.
Okay, and have any more question? No. Maybe if have no more question, then I would like to thank you all, that especially for everyone, and thank you for Shana for present your presentation today, and all for the present. Have another comments? Okay, thanks. And before we conclude everything, that I would like to share some news. Our next event for APMP EEFG International Workshop in 2025 will be held on next month, 28 to 30 October, focusing on strengthening collaboration for quality, and they already have some video for overview the workshop. Let's take a look.
Hello everyone! Indonesia is proud to host the APMP EEFG International Workshop 2025. With the theme Strengthening Collaboration for Quality of Sustainable Energy, this event brings together international experts and local Indonesian stakeholders. Held at Merdeka Hall Intermark DSD South Tangerang from October 28 to October 30. The program features an international seminar, site visits, and discussions on renewable energy traceability. Join us as we welcome distinguished keynote speakers and engage in thought-provoking panels on smart grids, EV station traceability, and solar PV testing. Don't miss this opportunity to collaborate, share expertise, and advance the future of sustainable energy. Register now and see you in South Tangerang this October.
And it's still available. If someone would like to join this workshop, then you can apply from the information. And this is the last but not the least that I would like to thank you for you all for joining us for our workshop from yesterday until today. Our team is very glad that you have a lot of questions and participate for your our workshop. We hope that maybe next workshop we can have that we can join again. Thank you everyone. Thank you so much. Thank you. See you next time.
Thank you. Thank you, everyone. Have a good day ahead. Bye-bye.
Bye-bye.
Bye-bye. Thank you, everyone.
Thank
Thank you,
you.
Red.
Thank you.
Thank you.
Siapa?
Okay, thanks a lot, Shana. Okay.
Thank you, Shana. Thank you,
Bye-bye.
all speaker.
See
Thank you, Shan.
Okay, thank you, Red.
See you.
Bye-bye. See you.
Bye-bye.
Goodbye, everyone.
Goodbye, everyone.
Goodbye.